Real numbers. Second part. So let us move on to the second section of the chapter, that is the fundamental theorem of arithmetic. Then, fundamental theorem of arithmetic is a simple theorem which connects the integer family of real numbers. That means it is about the integer family of real numbers, that is mainly the positive integer family of real numbers. Let us move on to it. Every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factor occurs. This is our theorem. Okay. What is this theorem is about? About a composite number and prime number. It is saying that every composite number can be expressed as a product of primes or can be decomposed as a product of primes. And the decomposition or factorization is unique. That is, only one and only one factorization is therefore composite number as the product of primes. Okay, let us have a look on what the composite number is. Prime number is a number with only two factors, that is that number and 1. Composite number is a number with more than two factors. Okay, what's a factor mean? Is something divisible to that number. For the example, 24, 6 is a factor by 6 divide 24, and by on dividing by 6 it will leave a remainder 0. Okay. If we have more than two factors, the number is categorized as composite number, and only two factors, that is categorized as a prime number. There are two exceptions in this case, 0 and 1. They are neither prime nor composite among the non-negative integers. Okay. Then, what is the theorem? Every composite number can be expressed as the product of prime. That is, every composite number equal to product of prime, that is 4 equal to 2 into 2, 24 equal to 2 into 3 into 4. And that factorization is unique. Unique means there exists only one and only one prime factorization for each composite number. This is our theorem. Then let's have some examples here. 8 equal to 2 into 2 into 2, that is prime factorization of 8. 21 equal to 3 into 7, 6 equal to 2 into 3. Also, this prime factorization is unique. You have to keep in mind that thing. Then let us move on to a problem. Consider the number 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So what we are going to use here is the fundamental theorem of arithmetic. That is, we are going to use fundamental theorem of arithmetic to show that, or to investigate that, whether the 4 raised to n ends with the digit 0. Okay. So for that, to prove last digit of 4 raised to n is 0 for some n, that is our problem. Okay. To prove or to check. For that, check the prime factorization of 4 raised to n. At first, we have to check the prime factorization of 4 raised to n. Since 4 raised to n is a composite number, we can express it in product of primes by the fundamental theorem of arithmetic. Here we are using our theorem. That is, we have an expression that says 4 raised to n. N can be any natural number. That is 4 square, 4 cube, 4 raised to 100, 4 raised to 1000, 4 raised to crore, 4 raised to something like that. then we have to check whether for any end 4 raised to n ends with the digit 0. Okay, you know something, which numbers have an ending with 0? That is, that numbers are factors of 10. Okay, that is 10, 20, 30, 40, 100. Every number is a factor of 10. Okay, or a multiple of 10, then it will ends with the digit 0. Otherwise, that number doesn't end with the digit 0. So, to check whether 4 raised to n ends with 0, we have to get 4 raised to n is a factor of 10 here. So for that, at first check what is the prime factorization of 4 raised to n. Then you know that 4 equal to 2 into 2. Okay. That is 4 raised to n equal to 2 square into n, which is equal to 2 into 2 raised to n. That is a raised to b whole raised to c is a raised to bc. That is a raised to m whole raised to n is a raised to mn. By using that, we will get 4 raised to n equal to 2 into 2 raised to 2n. Sorry, not 2 into 2 raised to 2n, which is equal to 2 into 2 into 2, 2n times. That is 2 cube equal to 2 3 times. The product of 2 3 times. 2 raised to 10, the product of 2 10 times. Here we have 2n. So the product of 2 2n times. So while checking here whether we have the factor of 10, the possibility of factor of 10 here, 4 raised to n. Here there is no, what are the factors of 10, prime factorization of 10? That is 2 into 5. Here we have 2, but the term 5 is not present here. So the 4 raised to n to become a factor of 10, we need a 5 here. That 5 is absent here. So whether we will get the last digit 0. So the prime factorization of 4 raised to n have only 2. Okay, no 5s. So the last digit cannot be 0 for any n 4 raised to n, because to get 0 as the last term, we need at least 1 5 as prime factor. Here only 2 into 5 gives 10 as the last digit 0. So what we can conclude? We can conclude 4 raised to n is a number which does not end with digit 0.
So moving on to next, we are using this fundamental theorem of arithmetic to find the LCM and HCF of two numbers. This is another important application of fundamental theorem of arithmetic. So we are applying this theorem to find HCF and LCM of two numbers. This is a quite easy process to find HCF of two numbers. So we have already studied about the Euclid division algorithm for finding HCF of any two numbers. It is somewhat a tedious process, so we are going to learn more easier method for finding HCF or LCM of two numbers. Okay. For that, let us have our procedure here. That is, let A and B are two numbers, then
HCF of AB equal to product of smallest power of each common prime factors in the number. What is LCM of AB? Product of smallest greatest power of each prime factor involved in the numbers. So this is our procedure is about. Okay. So how we are using our fundamental theorem of arithmetic here is that we know that every composite number can be decomposed as a product of primes. If A and B are two numbers, either prime or composite, if it is a composite number, we can decompose into it as a product of primes. Then how to find the HCF from that. At first, what we have to do, we have to decompose A and B as the product of primes. Then, what we have to check next, we have to compare all the prime factors of A and B and to find common among them. That is, common prime factor in those numbers. Then, what to next? From the common prime factors, we have to examine which is the smallest power among that. That is, if A have a prime factor 2 cube and B have something 2 square, we have to compare both and take 2 square from that. That is smallest power from that. And next, if A have 3 square and B have 3, we have to select 3 from that. Then what is our HCF is all about? 2 cube into 3. Okay. That is, we have to find which is the smallest power of common prime factors among that, and just we have to multiply those numbers. What about LCM? Similarly, we have to compare each prime factor and find greatest power among that and multiply that greatest power in order to find the LCM. That is, if we have 2 and 3 in one and 2 square and 3 square in another, then what we have to do, we have to multiply 2 square and 3 square in order to find LCM of AB. Okay. So, another result also was there, that is, there is a connection between HCF of AB and LCM of AB, that is, HCF of AB into LCM of AB equal to AB. This is also a useful result that we can use to find HCF and LCM. So what is an HCF and LCM? HCF is highest of common factor among them and LCM is least common multiple. Multiple means what? That is, what are multiples of 2? 2 into 2, 4, 2 into 3, 8, that is 4, 8, 16, etc. are multiples of 2. That is, something is multiplied by 2, we will get the multiple. That is, in order to find LCM, we have to find least common multiple among A and B. Okay. So, let's have a look on one problem. Example here, that is, find HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. This is our problem. Okay. What is our problem is about? We have to find HCF of 96 and 404 by prime factorization method and to find their LCM. So, let us have a look on that. That is, at first we have to do the prime factorization of 96. What is 96? 96 equal to 48 into 2. That is, 48 is 6 into 8. That is, 6 is 3 into 2. 8 is 2 into 2 into 2. That is 2 cube into 2. This is the prime factorization of 96. What is next step? We have to count how many prime factors are here. That is, 2 have 5 prime factors and 3 have only 1. Then we have to rearrange it as 96 equal to 2 raised to 5 into 3. Then what about 404? 404 equal to 202 into 2, that is 101 into 2 into 2. That is 202 equal to 101 into 2 into 2. Then after rearranging, we will get 404 equal to 101 into 2 square. So we have our prime factorization here. What is next step? Next step we have to compare things. So at first we can arrange this as 96 equal to 2 raised to 5 into 3 into 101 raised to 0. Why we are giving a 101 raised to 0 is here? Because here we have no factor such that 101. In order to compare the common prime factors, we are adding a 101 raised to 0 here. Okay. Similarly, in the case of 404, we are adding a 3 raised to 0 here. So why we are adding this 101 raised to 0, 3 raised to 0 is because we already know that a raised to 0 equal to 1. So by adding this term does not make any change to this value. That is, for just a comparison, we are adding this term. If you can avoid this, you can avoid. No problem is there. But if it is better if you add something like this. In next, what we have to do, we have to compare these terms and find smallest power of common prime factors. Okay. That is, here we have 2 raised to 5, here we have 2 square, smallest among them is 2 square. And here we have 3 raised to 0, smallest among them is 3 raised to 0. Here we have 101 raised to 0, smallest among them is 101 raised to 0. What is our prime factorization then? For HCF then, 2 square into 3 raised to 0 into 101 raised to 0. These two terms equal 1 and 2 square gives our HCF, which is 4. So next we have to find our LCM. How we can find our LCM? We have to compare product of greatest power of each prime factor involved in this number. So we are not going to do that method. We are going to do by this method. Why we are adopting this method? By leaving this is because of this question. What the question is? Find HCF of 96 and 104 by prime factorization method. Hence find their LCM. It means through HCF we have to reach our LCM. So this method is better for that. Okay. That is, through our HCF we have to reach our LCM. Then what is LCM of AB? AB by HCF of AB. That is, we take this HCF here, we will get what is LCM of AB is. Now by providing the values, we will get LCM of 404 into 96 equal to 404 into 96 by 4, which is 9696. Okay. This is our required LCM here. Now, here we are applying this prime factorization method to the composite number. So, what if we have two prime numbers? Oh, in order to find HCF and LCM, what is an easy technique regarding that? That is, if A and B are two primes, then what is HCF of A and B? That is 1. That is highest common factor among any two primes equal to 1. That is 3 and 2. 3 and 2 have only common factor, that is 1. Then what about 101 and 2? 1. That is, if we have two primes, HCF can be easily found out, that is 1. Okay. We can find HCF easily, that is 1. What about if A and B are primes, then LCM of AB? LCM of AB equal to A into B, that is least common multiple. In order to find A and B are primes, and our adopted method is that just multiply those numbers, then that will be our least common multiple. That is 101, 2, 202, 3 to 6. That if we take another prime, 13 into 13 into 11, what is our LCM? 143, that is 13 into 11.
So let us move on to the next problem. Find the LCM and HCF of 6 and 20 by prime factorization method.
So what we have to do, we have to find LCM and HCF of 6 and 20 by the prime factorization method. That is, we are not supposed to use HCF of AB into LCM of AB equal to AB. Only by prime factorization we have to find the HCF and LCM of these two numbers. So, before moving on to that, Let me explain what is actually LCM and HCF is to those who have forgotten the thing that we have studied in lower classes. Those who know it already, you can skip and move on to answer. So, what is an HCF? That is highest common factor. So, in order to find HCF of 6 and 4, at first we have to find what are the factors of 6. That is, what are the factors of 6? Those numbers which are completely divisible on 6, that is, on dividing to 6, we will get a remainder 0. That is, that numbers are 1, 2, 3 and 6. That is 6 divided by 2 we will get 0. 6 divided by 3 we will get 0. Then what are the factors of 4? 1, 2 and 4 are the factors of 4. That is, on dividing by these factors 4 we will get a remainder 0. Then what is HCF? We have to compare these factors and find highest common factor among them. What is the highest common factor here? 2 is common, and 1 is a common factor, 2 is a common factor, which is highest among that? 2. So HCF of 6 and 4 equal to 2. Then what about LCM? Is the least common multiple. So in order to find LCM, we have to find multiples of the numbers. What are the multiples of 6? 6 into 1, 6. 6 into 2, 12. 6 into 3, 18. 6 into 4, 24, etc. Multiples of 4. 4 into 1, 4. 4 into 2, 8. 4 into 3, 12. 4 into 4, 16. 5, 26, 24, etc. Then we have to find which are the common among them. That is, 12 is a common multiple. 24 is a common multiple. LCM is least common multiple among them. What is the least? That is 12. This is our LCM. So, instead of doing this long procedure, we are finding LCM and HCF shortly by using this prime factorization method. So, moving on to next, what is 6? Prime factorization of 6? 2 into 3. What about 20? 4 into 5, that is 2 square into 5. Now, we are rearranging this, that is 6 equal to 2 into 3 into 5 raised to 0. Since 5 term is absent here, we are adding a 5 raised to 0. Why? 5 raised to 0 is 1. Then what about 20? 2 square into 3 raised to 0 into 5. That is 3's term is absent here, so we are adding a 3 raised to 0 here. Then, to find HCF, we have to compare these and find least power among these common factors. That is, by comparing 2, least among them is 2. That is 2 square and 2, least is 2. Comparing 3, least is 3 raised to 0. Comparing 5, least is 5 raised to 0, which is equal to 2 into 3 raised to 0 into 5 raised to 0, 1, which is equal to 2. 2 into 1 equal to 2. Then what about LCM? LCM of 6 and 20 equal to comparing the factors and finding highest among that. That is highest power among that. That is 2 and 2 square, 2 square. 3 and 3 raised to 0, 3. 5 raised to 0 and 5 raised to 1, 5. That is 2 square into 3 into 5. That is 4 into 3, 12 into 5, 60. So, we have find our LCM and HCF here. Next, moving on to next problem. Find the HCF and LCM of 6, 72 and 120 using prime factorization method. So, we have to find the LCM and HCF of 3 numbers here. Okay. So, what is 120? That is 40 into 3. That is what is 40? 8 into 5. That is 8 into 5. That is 2 into 2 into 2. 2 cube. 8 into 5 and our 3. So, if you have any difficulty on doing like this, that is by mind calculation, you can use the factorization method here. That is, 120 is divisible on by 2. That is, 2 can divide 120. Then 120 by 2 will give 6. Next, prime factor can divide 60 is 2. That is 60 by 2, 30. Again 2 is divisible on 30. Then 30 by 2 we will get 50. 2 is not divisible on 15. So we are using here next prime factor 3. That is 3 we will get 5. Another prime factor 15 by 3 5. So now by arranging this we will get 2 cube into 3 into 5. You can utilize whichever method you like. Okay. Then what is 6? 2 into 3. That is we are adding a 5 raised to 0 since 5's term is absent here. Then what about 72? 2 cube into 3 square. That is 8 into 9. Into 5 raised to 0 since 5 raised to 0 5's term is absent here. Now how to find HCF? HCF is least common power of the common prime factors. Okay. Then by comparing these twos, least among them is here we have 2 cube, here we have 2, here we have 2 cube again, which is the least 2. Then here we have 3, 3, 3 square. Least is 3. 5, 5 raised to 0, 5 raised to 0. What is least? 5 raised to 0. Then what is our HCF? 2 into 3, 6. What about LCM? Is highest power. Okay, by comparison 2 cube, 2 cube, which is the highest 2 cube. Then 3, 3, 3 square, 3 square. 5, 5 raised to 0, 5 raised to 0, 5 raised to 1 here. So 5, 5 raised to 1. Then what is this? 8 into 9 into 5. Okay, which is 360. So here we have our LCM and HCF. Then we have an important result here, that is LCM of ABC into HCF of ABC not equal to ABC. That is, just in case of two numbers we cannot write LCM of ABC into HCF of ABC equal to ABC. The result is not true here about three numbers.